Hello and welcome to York Observatory YouTube, TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Quinton, and I'll be one of your hosts this evening, alongside Professor Hyde, Matt, Arfa, and Sergiy. We are broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. But if you can't make it to one of our live shows, don't worry. All our teletubes are recorded and uploaded here on our YouTube channel, so you can watch them whenever you want. If you have any questions or comments about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @YorkObservatory, or on Facebook at Alan I. Carswell OBS. Good evening, everyone. Tonight, my co-hosts and I have prepared a presentation for you to get you all prepared for the Annular Eclipse happening tomorrow, Thursday, June 10th. We'll be introducing the concepts of both lunar and solar eclipses, providing some information about where and when the annular eclipse happening tomorrow will be occurring, and giving you some pointers on how you can observe it safely. We also plan to host a follow-up presentation tomorrow at 2 p.m. local Toronto time, where we'll be sharing any images we're able to get of the big event. So even if you aren't able to see it yourself, why not drop in tomorrow for a nice little retrospective with us? Now, before we start the presentation, I'd like to tell you about some astronomical objects that you might be able to see in the sky this week. First up, of course, is the star of tonight's event, no pun intended, the solar eclipse. If you're listening to this presentation in the Toronto area, then you might be able to see it for yourself, as long as you've got the right safety equipment, good weather, a clear view of the horizon, and are willing to get up early. That's because the moon will be nearest the center of the sun right when it's rising, which will be at 5:35 a.m. tomorrow. The eclipse reaches its maximum in our area, at which point 80% of the sun will be covered a mere 5 minutes later. Keep in mind that because of our geographical location, Torontonians won't be able to see the eclipse take on its amazing annular shape, like observers elsewhere will. Remember that appearing centered in the sun and forming a ring, the moon will, rather than appearing centered in the sun and forming a ring, the moon will be offset. So even at its greatest extent, the eclipse will only be a partial one from our perspective. The moon will move out of the way of the sun at 6:38 a.m., and then both will continue to rise as normal. For those of you living elsewhere, a great resource to check if the eclipse will be visible at your location is timeanddate.com. As a reminder, as exciting as an event like this is, do not try to look at it unless you have sufficient eye protection, such as proper eclipse-rated glasses or a pinhole camera. We'll show you how to make one of those later. The sun is still the sun, even during a solar eclipse, and it's still fully capable of damaging your eyes if you stare at it. Fortunately, there are plenty of other pretty lights in the sky that it's perfectly safe for you to look at with your naked eye. For example, there's Venus, which is perfectly safe to look at despite being the planet that appears the brightest from Earth. The sun sets over Toronto at 9 p.m. tonight, and that's the perfect time to try and get a peek at Venus, as it will follow it over the horizon around 10:30. The red planet, Mars, will trail just a bit behind Venus, setting at 11:45. Castor and Pollux, the brightest stars in the constellation of Gemini, will be visible right near Mars in the western sky. With binoculars or even the naked eye, you should be able to distinguish these two bright stars by their color. Pollux shines an orangish color, while Castor is a brilliant blue. If you have access to a high-quality telescope, though, here's a harder challenge. Can you make out that Castor is actually more than one star? It's actually a sextuple star system. That's 6 stars. But even just resolving the second point of light of Castor B is a considerable accomplishment. Other bright stars in the Toronto sky include Capella in Auriga, Arcturus in Boötes, and Vega in Lyra. If you're up late, keep your eye on the eastern sky. Saturn rises around 12:30 in the morning tonight, and Jupiter will follow it around 1:15. If you have a telescope, why not try to resolve Saturn's rings or Jupiter's Galilean moons? So now that you know about the other exciting astronomical bodies you can observe this week, it's time to get started with the main event. I'll pass the mic over to Professor Hyde to introduce us to the topic of eclipses.
Well, thank you very much for having me over, and thanks for that great intro, Quentin. It's very, very tempted to get distracted by all the wonderful views up in the sky. But before we go too far along there, let's go ahead and have a little think about our place in the solar system to see how do eclipses work. So most of us are familiar with the idea of the Earth. Hopefully, we're standing or sitting on it. So we have this wonderful round planet sitting in space, and the moon goes around us. Well, that's true, but the moon and Earth both go around the sun. So, how does this all come together? Well, and how do we get eclipses from it? Well, in this little diagram I've put up here, you'll notice only one of these three things emits light, and that is, of course, the sun. As mentioned by Quentin, it is very, very bright and very capable of damaging your eyes. But because the sun is shining from one direction, as the moon goes around the earth, we can then have it either shine the moon's shadow onto Earth or Earth's shadow onto the moon. And so this is how we're actually going to be able to get eclipses from seen from our little Earth surface. And it's actually a great sort of time of the year for eclipses. We have the 2021 eclipse season, which is happening right now. As you may have heard, we had a lunar eclipse on the May 26th this year, so just a little bit ago. And the annular solar eclipse is coming up tomorrow. So this is not unusual. These eclipses usually happen in pairs, but this specific pair is a little bit odd because the lunar eclipse on the May 26th was fairly short. Its totality only lasted about 14 minutes, and the annular solar eclipse will actually be rather long for a solar eclipse. I believe it's up to the fifth longest worldwide duration. So we get these eclipse pairs happening because we have, once you have a good alignment, if you get your lunar eclipse, your solar eclipse is relatively sure to follow. So we have this wonderful eclipse season, and being based in Toronto, it's always interesting to see what's going on with eclipses in Toronto history. And so I'd just like to give a little shout out to the Ontario Parks blog, and we have Bruce Waters with some guidance by Melanie Demers, who've pointed out in their blog that it's actually been known for a long time that solar eclipses are very important in several local North American confederacies, in particular the Confederacy of Peace amongst five of the Haudenosaunee nations. So, and this is a little bit of interesting Haudenosaunee oral history. If you'd like to find out more about that, make sure to check out their blog on Ontario parks for annular eclipses. It's quite fun. So let's go ahead and think about these a little bit more in context. So I said that, of course, with different eclipses, we could have the shadow of the moon shining on Earth or the shadow of the Earth shining on the moon. If it is the shadow of the moon shining on Earth, which you're actually going to hear about quite a lot from some very cool people later on, so I'm not going to talk about this a ton, but this is going to get you your solar eclipses. So your solar eclipses will be things like annular eclipses, which is what is happening tomorrow, or partial, which is what we'll be able to see from Toronto, or total, the most rare and sort of cherished of all the eclipses, the hardest to see, and of course, one of the most spectacular. So the Earth and the Moon both cast shadows because there's only one light source out there in space. It's the sun. And if they pass through each other's shadow, we have an eclipse. So this is the general idea. Now, if I go the other way and I have the moon going behind the Earth, well, this is going to get me my lunar eclipses. So the lunar eclipses are, maybe less spectacular, but they're much, much more visible. So the lunar eclipse is visible by the entire side of Earth that is in nighttime when the moon goes back into its shadow. And you'll notice in the diagram here from NASA, the moon becomes red. And so this is sometimes called a blood moon, which those of you in May will have heard in at least a few news channels. And you'll note that on the right here of the image, you can see that it does require the moon, the sun, and the earth to all be in line. And the better the alignment, the more spectacular the eclipse. So if we've got this great setup for eclipses, what then happens with the moon? Well, as the moon passes through its orbit, it actually travels through the shadow of the Earth. And so this is a series of pictures of the moon, actually taken by Philip Morel as an eclipse was happening. And so you can actually kind of get an idea from this how big the shadow of the Earth is out there. And as we see the moon go through, you see you've got your full moon and it travels through the shadow. So if your alignment is very good, it would travel straight through the shadow of the Earth and you'd have a bright red moon in the center, which is what's happened here. And it comes out the other side. Now you'll notice in this case with a lunar eclipse, I cannot get an annular eclipse. It is impossible because the shadow of the Earth is too big. So the solar eclipse that we are having tomorrow is annular if you can get yourself into the right location. But that's only because, of course, the distance from the moon to the Earth has, become slightly larger, so the moon becomes smaller. If it's a lunar eclipse, the shadow from the Earth is so big, it's never going to get a chance to be annular. It can be partial by being not quite aligned with the sun and the Earth. It can be partial and go through only part of Earth's shadow, but it can never be annular. So it's quite fun. There is a little typo on the actually, that's not a typo. Good for me. All right. So partial, total, and penumbral. So penumbral is if it only goes through the side of the shadow. So just to call that out. Alrighty, so now we've covered a little bit about the lunar eclipses, we've covered about the moon, and one final little shout out here, our most recent lunar eclipse, a shorter eclipse, as I mentioned before. This particular eclipse season had a very, very short little eclipse, and we did not get to see it here in Toronto or, in fact, Ontario or Canada, almost all of Canada, actually. So, because it was actually the wrong side of Earth. So, Toronto was on the wrong side of the planet for this eclipse. Australia was on the right side of the planet, and a little tiny, tiny bit of North America was also able to be, sort of on the right side to see this lunar eclipse on May 26th. So, what you see in the video is Griffith Observatory in California, in the United States on the West Coast. They are having some clouds, but this was their coverage of the lunar eclipse, which they got to see part of. So they had a partial lunar eclipse from there, I believe. Now, at the left-hand side of the image, you can see where on Earth you would have had to stand to get a good view of this lunar eclipse and why we did not see it in Toronto. So indeed, the Earth being round, it does not always line up how we would like it to. So our more recent shorter eclipse will come along with a fairly long um, partial solar eclipse. And as a reminder to all of our viewers, again, as Quinton said, we will be having a special viewing of all the images we managed to collect from the Alan I. Carswell Observatory from Toronto's partial eclipse tomorrow on this very channel from 2 to 3 p.m. So I am going to go ahead and hand it over to one of our wonderful, wonderful crew, Matt, who is going to take it away and talk more about those fabulous solar eclipses, including the partial solar eclipse like the one we'll have tomorrow morning in Toronto. Take it away, Matt.
Oh, well, thank you so much, Professor Hyde, for letting us know what lunar eclipses are. But as you have heard from Professor Hyde herself, we don't only have one type of eclipse, but rather two. And it really depends on which object will be in front of the other from our point of view. And it will mostly be referring to our position, our shadow's position, the sun for obvious reasons, and the moon. And for solar eclipses, the sun appears to be behind the moon, blocking it entirely. And this effect is thanks to the fact that the sun's diameter is about 400 times larger than the diameter of the moon. But it also happens to be 400 times farther away than the moon is, making it appear more or less the same size. But what happens when the moon comes in front of the sun? Does it make the whole sky turn dark? Are we able to see anything at all? What happens when we are at a different location on Earth? Is there more than one kind of solar eclipse? And if so, what are the different eclipses? All of that will be covered in this section. So let's start with the main question. What happens? Let's say that you happen to be in exactly the right spot to see total alignment and therefore a total solar eclipse. This would mean that you're in a part of the moon's shadow, which is called the umbra. You may think that a solar eclipse is as simple as I mentioned before, just the moon blocking the sun, and that's it. But just think about it for a minute. What does it really take position wise for the moon to actually cover the sun in such a perfect way? It doesn't happen every single day or month, does it? Well, that's because there's a lot more into it. First thing we have to take into account is the difference between the moon's orbit around the Earth and the ecliptic. If you don't know what the ecliptic is, it's just the plane at which the Earth orbits around the sun, or the path that the sun takes through the sky from our perspective. This path is different from the one of the moon takes, and having a difference of about 5 degrees. And moreover, the moon has an apogee and a perigee, which are some fancy words used by us astronomers to say when it is farther away or closest to us. When the moon is near its apogee or far away from the Earth, it will appear smaller in the sky. And tomorrow, as a matter of fact, we will have the moon farther away, which is why we are able to get an annular eclipse, which I will be talking later on. Um, Although there isn't a total solar eclipse tomorrow, as I said, they are one of the most interesting eclipses. So let's discuss them a bit more. Let's go back to the instance at which the moon's orbit intersects with the ecliptic. The intersections will happen 180 degrees apart from each other, which means that during the year, there's at least 2 times in which there would be at least one solar eclipse happening. And it can go up to 5 solar eclipses. But don't get me wrong, because what everyone's so hyped about during these times when the total solar eclipses happen, it's not a common deal, since the distance and hence the size of the moon happens to be perfect for us to have a total solar eclipse. And as you may infer from the word total again, the new moon is intersecting the ecliptic at its largest size, blocking all of it, all of the sun, if you're in the umbra, of course. And there are also eclipses that can be seen as a partial blocking of the sun, which will happen in Toronto tomorrow. But that actually depends on your location on Earth. Again, if you're in the Umbra, you'll be the lucky one to experience the total solar eclipse and see the solar corona surrounding the moon for some minutes and creating what some call the diamond ring effect. But for some, that won't necessarily be the case. And if that happens to be you, then you would be located in the penumbra. In the penumbra or in a partial solar eclipse, the sun and moon do not line up perfectly from your perspective, and only a smaller, substantial amount, a portion of the sun will be blocked depending on how far you actually are from the umbra. In this case, you will be able to see a reddish orange part of the sun, while the other part appears to be dark, which is the most common type of eclipse, as a matter of fact. And now, if the apparent size of the moon happens to be smaller than the apparent size of the sun, which is actually what happens 60% of the time if you happen to see a solar eclipse from the umbra, that will be what's called an annular eclipse. Since the size of the moon is small in comparison, the effect at which every single part of the sun is blocked and you will be able to see the solar corona won't actually happen. But don't worry, because there's still an amazing effect being created by this scenario. Because a ring of fire up in the sky will be created by the unblocked portion of the sun, and this glowing ring is also called an annulus, which is where the name of this eclipse comes from, and it is the most common type of solar eclipse that can happen. And if you're a little bit rusty on your geometric or mathematical knowledge, as I was before this TeleTube, an annulus is the region between two concentric circles, shaped like a ring, as we can see it for the sun, and as we can see in the image on the right. And now that you know what this is all about, let's see what is actually going to happen during tomorrow's eclipse.
Thank you, Matt. So now we know about the different types of eclipses. On June 10th, though, we are expecting an annular or partial eclipse depending on where you are observing from. As mentioned earlier, in Toronto, solar eclipse will be occurring at sunrise when the moon will become apart from the sun. The moon will appear smaller than usual as it will have reached its apogee, the furthest point in its orbits from Earth, just a few days previously. For this reason, the moon will appear smaller than the sun in the sky. So in the parts of the world where the two objects line up, an annular or ring-shaped region of the sun will be visible peeking around the edge of the moon. The eclipse can be viewed from different angles at different timing. Viewers from Toronto or its neighboring cities will be viewing the partial eclipse on June 10th at 5:46 a.m. and maximum eclipse at June 10th at 5:01 a.m. All of these timings are local Toronto time. If you plan on viewing the solar eclipse, you should be facing towards the east, but make sure there are no buildings or obstacles blocking your view. As the sun, the moon will be right near the horizon at this time of day. Unfortunately, in some places, the viewers won't be able to view the ring, but they can still view the partial solar eclipse. Along with Toronto, many parts in Northern America will be able to see the eclipse, and parts of the eastern United States and northern Alaska will see a partial solar eclipse on June 10th, along with much of Canada and parts of Europe and northern Asia. In many of these locations, the eclipse will be visible around sunrise, so you'll need to clear a view of this horizon to see it. The full annular eclipse will be visible in northern Ontario up to the north bank of Lake Superior around James Bay and the Ungava Peninsula in northwestern Quebec, most of Baffin Island, northwestern Greenland, and in some of the far eastern part of Siberia. The next solar eclipse you will see in Toronto will be on October 14, 2023. That will also be a partial solar eclipse. Does anyone remember when the last solar eclipse in Toronto was? Well, if you guessed August 21st, 2017, then your guess was right. Dubbed as the Great American Eclipse by the media. A partial solar eclipse was seen, including all of Northern America, particularly areas just south of the Totality Pass, where the eclipse lasted about 3 to 5 hours. Northern South America, Western Europe, and some of Africa and Northeast Asia. The next really good total solar eclipse will be in 2024 and will pass right through Ontario. So there's a lot to look forward to. Please be cautious when looking at any solar eclipse. It's very dangerous to look at direct at the sun. There are some precautions that can be taken when observing an eclipse. Do not look directly at the sun. Do not use homemade filters or ordinary sunglasses, even very dark sunglasses. Use special purpose solar filters such as eclipse glasses or handheld solar viewers to view the eclipse. Read the follow filter instructions and supervise children. In any stage of eclipse, do not look at the sun through a camera, telescope, binoculars, or other optical device. And never use solar filters with these devices as concentrated solar energy will damage them. And you can use serious eye injury. Pinhole projection is a safe way to view the sun in an indirect fashion, and here to provide a tutorial on how to make one for yourself is Sergiy.
Thank you, Arfa. Now that you know the severe consequences of not taking your safety into account, let's take a good look at the eclipse using a pinhole camera. Before we discuss how to build a pinhole camera, let's first discuss what a pinhole camera even is. A pinhole camera, in principle, is really simple. In the most basic terms, it's a tiny hole that projects only a small portion of light. If we have an image plane and an object in front of it, photons hit the object and then hit the image plane, and thus we could see an image. The problem lies in the fact that photons that hit the same parts of the object can hit different parts of the image plane, and other photons that hit differing parts of the object will hit the image plane in the same place, as you can see on the image to the left. Because of that, the image plane will not show a single crisp image, but a blurry mess. Lenses usually focus light from a certain distance, but the foreground and background will be blurry since the lens won't be able to focus light that originated at a different distance. Pinhole cameras will, instead, only let a small amount of light pass through. By doing this, the photons that hit the object will only be seen in the respective arrangement. Only a small segment of photons pass through the pinhole, and it depends on the angle of the photon. So if a photon hits the top of the object, you'll only see it at the bottom of the image plane. Whereas if a photon hits the bottom of the object, you'll only see it at the top. Since every photon is ordered correctly, this results in a clear image, as you could see on the right. Due to the fact that only select photons pass through, the entire image will be in focus, which is really interesting. Though it will be darker than as compared to a regular camera, since less light is allowed to enter. Our eyesight works similarly in that it also sees a flipped image, but our brains are wired to reverse the image. There are many different ways to make a pinhole camera, and all of them work well. The most basic one is making a small hole using your hands or fingers, though it will be dimmer than the following methods. The next easiest one, promoted by NASA, called Pinhole Projection, requires you to project the eclipse on a piece of white cardstock on the ground, whereas you stand with your back facing the sun, holding a flat pinhole camera. To make it, you need 2 pieces of white cardstock. Compared to paper, cardstock is thicker and more durable, whereas compared to cardboard, it's thinner and more flexible. You also need aluminum foil, tape, and something to make the pinhole, i.e. a pin or paper clip usually are the best options. To make it, first fold the one page of the white cardstock in half and cut out a square on the hinged side, so when you unfold it, there's just a square hole in the center of the white cardstock, as you can see on the image to the left. Then you tape a square piece of aluminum foil so that it fills in the empty square hole. Pin a tiny hole in the aluminum. Remember to have the aluminum facing up towards the sun, but be careful to not look at it. Rather, keep your eyes on the shadowed regions of the cardstock on the ground. And when the eclipse is happening, make sure to direct the light onto the other white cardstock on the ground to see the eclipse safely. The best way to line up the eclipse onto the white cardstock is to align the shadow of the cardstock you're holding onto with the cardstock on the ground. If you want the image of the eclipse to be even more defined, try having the bottom cardstock, or the image plane, in a shadowed region, whereas the cardstock in your hand is in sunlight. Also, again, remember not to look into the bright beam of sunlight. Another way you can do it is by taking an old shoebox and cutting a square hole with a width of around 1 inch, or around 2.54 centimeters, in a corner of one of the short sides of the box using an X-Acto knife. Tape a piece of aluminum foil so that the entire square hole is covered. Then pierce the aluminum foil with a needle or paper clip, i.e. the pinhole. Then inside the box, tape a piece of paper opposite to where the aluminum foil is. The paper is the image screen. Then cut another square hole across the corner of the paper. This will be the hole for viewing the sun on the image screen or the eyepiece. Make sure to be looking through that hole, looking away from the sun. That's very important, away from the sun, where the pinhole camera is facing towards the sun so that you can line it up with its own shadow. Most professional astronomers use a different method called optical projection, where they use a lens, though the bright light can damage the equipment, so only professionals do it, to project a large and bright image. Another way, as used by York University, is to use a solar filter or a sun funnel. They're the same thing, it's just a different name. As you can see right now on the telescope on the right, the white cap is the solar filter. Looking into the telescope, into the telescope, your view will be completely black since the solar filter is mostly opaque. But since the sun is really bright, when you look at the sun, you'll see a white circle. In addition, you can also see sunspots on the sun through the solar filter. The following images that you see on your screen right now were taken by York University's own sun filter telescope, the one you saw on the right just recently. The image on the left were captured using the solar filter and a filter sensitive to the hydrogen alpha emission line, which is why the sun appears so red. On the right, you can see Venus transiting in front of the sun. We won't be able to see Venus this time, but hopefully we'll be able to get a lot of great images of the partial eclipse to share in our next broadcast. We are very excited for this event, and although it is quite early tomorrow, this is to say Thursday the 10th at 5 a.m., we will be broadcasting a quick recap of all the images our observatory crew has obtained on this channel from 2 to 3 p.m. Eastern Standard Time. Make sure to join in and see all the eclipse fun. Well, everyone, you have been listening to Alan I. Carswell Observatory's weekly TeleTube broadcast, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The host this evening have been Quinton, Dr. Hyde, Matt, Arfa, and myself, Sergiy. Make sure to leave any comments or questions in the comment section of the video and talk to us in chat right now. We'll be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation or buy one of our observatory astrophotography calendars, now at a 50% discount, see our website at observatory.info.yorku.ca. You can always connect with us on Twitter with the handle @YorkObservatory and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.